The melting furnaces are very important for melting the metals or alloys. This is a heating device used for heating and melting, and for providing heat to chemical reactions to take place for processes like cracking, etc. And the furnace these furnaces are heated by various fuels. As in many furnaces, the coke is used as a fuel, and some are operated by electrical energy in case of electrical arc furnaces. The most commonly used furnaces which we have in actual practices are cupolas, direct fuel fired furnaces, crucible furnaces, electric arc furnaces, induction furnaces. So this is a schematic representation of an electric arc furnace where the heating filament is very important for melting of these metals or alloys. Here it consists of 3 electrodes, and it also have a removable roof, and inside this furnace we have refractory lining, and we have a tapping spout to bring the molten metal outside, and it will have some tilting arrangement so that with the tilting mechanism, so that it can be tilted and the molten metal can be dropped into the crucible or the buckets. Here the charge we call it as the mixture of that is, for example, in case of steel and coke, the charge melted by the heat generated from an electric arc. So here the electric arc is stuck between 2 terminals, or here 3 electrodes, so that the molten metal would be obtained by melting because of this heating. So high power consumption, it requires more power, but the electrical furnaces can be designed for high melting capacity also. So it has either from low capacity to high capacity, the electrical furnaces can be designed, and generally it is used for melting steel. And here this is an induction furnace. It uses an alternating current passing through a coil. So we have a magnetic coil. So when the current passes, so the alternating current would be passed through the coil. Because of this, the magnetic flux intensity produced, which is used for heating and melting of the metals or alloys. So here the induced current causes rapid heating and melting, and the electromotive force, that is EMF, shortly we can call, this EMF field also causes a mixing action in liquid metals. So if suppose we have various metals in various grain sizes, so when the heating it, all will melt at its melting point, but the mixing of action can be influenced by this particular electromotive force. And since the metal does not contact the heating filaments, because the heating filament is outside, you just see in the figure. So the heating filament is outside the copper induction coils. So it is not in contact with the metal or molten metals. So it can be controlled greatly to produce the molten metals of high quality and purity. Generally used for steel, cast iron and aluminium alloys.